For the first time, astronomers have seen the colossal merger of neutron stars and black holes about 900 million light-years away from the Earth. This means that the merger took place 900 million years ago, when complex life forms did not even appear on Earth. It's a collision of two of the most exotic and densest objects in the observable universe. But why are astronomers so excited about it? How important is this discovery? And most importantly, how did they detect this dynamic merger from trillions of miles away? To answer all the questions, let me first introduce you to these fascinating objects. Black holes are monsters of the cosmos. They are so massive and dense that even light cannot escape their gravitational pull. On the other hand, neutron stars are the dead stars that are again incredibly dense. A teaspoonful of material from a neutron star is estimated to weigh in about 4 billion tons. Although both of these objects are cosmological beasts, black holes are considerably more massive than neutron stars. According to general relativity, when massive objects merge, they produce gravitational waves. These are basically the shock waves that propagate in the fabric of space-time. For a simplified version, think of ripples originating in water when disturbed in one way or the other. As the gravitational waves propagate through the fabric of space-time, they stretch it in one direction and compress it in the other. It is like pulling a rubber band. When we pull it, it gets elongated on one side and squeezes the other side. The measurement of this distortion in space-time helps in the detection of gravitational waves. But why is that so challenging? When gravitational waves hit something and stretch and compress it, isn't it easy to measure that? The answer is no. Why? Because by the time the waves reach the Earth, their magnitude decreases significantly. The stretch and compression produced by a gravitational wave are equivalent to the 1,000th part of the diameter of a proton. In 2015, 100 years after Einstein's prediction, LIGO reported the first ever detection of gravitational waves, and since then, physicists have never looked back. Over the years, researchers have observed dozens of merging black holes and a couple of merging neutron stars. The merger of a black hole and neutron star was predicted, but it was never observed. Now, we finally have a glimpse of it by observing the unique ripples in space-time caused by such a collision, and that too, not only once, but twice. Both the observations were first made in January 2020, just 10 days apart. Although the first observation wasn't definite, looking at the signature, it was suspected to be an outcome of a merger between a black hole about 9 times the mass of the Sun and a neutron star about twice the Sun's mass. The event took place between 550 million and 1.3 billion light-years away from Earth. Another spectacular observation was made by 3 facilities just 10 days later. This time, the merger involved a black hole nearly 6 times the mass of the Sun, devouring a neutron star about 1.5 times the Sun's mass. Moreover, the merger appeared to have taken place between 650 million and 1.5 billion light-years away. Hence, approximately 900 million light-years away, 2 black holes gobbled up their neutron star companions. The event triggered gravitational waves that finally hit Earth in January 2020. But it is still unclear where and how did these binary systems form. Scientists have arrived at 2 major theories to explain this merger. One such theory says that each member of a binary star system independently went supernova. The explosion further formed 2 dense remnants that eventually merged. The other theory says that different stars experienced supernovae explosions and later established a binary relationship and merged. The observations have led to predictions that one merger between a black hole and a neutron star occurs once per month within 1 billion light-years of Earth. Although the collision observations have opened up many new doors of impending discoveries, neither of them hinted at the appearance of light signals. Any light emitted would have dimmed by the time it reached the Earth. Hence, these 2 observations aren't enough to determine what's actually going on there. 4 gravitational wave detectors are currently undergoing preparations for another set of observations scheduled to begin next summer. But one thing is for sure, With the advancements in future detectors, numerous amazing mysteries are about to unfold. Do share this video with your friends and follow us for more exciting videos on physics and astronomy.